Welcome to Hill Murray. We are the Droneers, and we as a team are thrilled that during the Drone Exploration Challenge of an unknown planet, we found evidence of life through dinosaur fossils and microscopic plant debris, valuable minerals such as iron, an abundance of water, temperatures and pressures that would be suitable for human life, possible advanced intelligence through eye charts that are symbolic of hieroglyphics, and a stunning light phenomenon that puts the aurora borealis to shame. These findings could be similar to those found on other planets.
I'm Philip Rother. I'll be talking about Censor Suite 1 today, and Censor Suite 1 was used to measure magvec and temperature, and it consists of the Adafruit Featherhusa, which is the microcontroller, and the Melexis contactless temperature sensor, and the LSM9DS1, which is the magvec sensor. So for the walkthrough data, which we use telemetry for with Adafruit IO, the magvec sensor data, we got a like about -5 to +5 while it varied for the X and Y, and they were inversely related. So each time X went up, Y went down, and vice versa. And we got changes in magvec for both those fields when we rotated the envelope 90 degrees. So the mag sensor measured positive X this way, positive Y this way, and each time the magnetic field was measured this direction, we would get negative X, and this direction got negative Y, and same for positive Y and positive X, which was a good thing. So for envelope C, during the walkthrough, we got temperature data, and it varied about 15 degrees at its peak. So that was a good thing. It means our temperature sensor was working.
In the fly-off, because of various problems with microcontrollers and Wi-Fi, we were unable to get the information we needed and had to fall back on walkthrough data to be able to use live telemetry as well as our information. Hello, my name is Paul Melby. So the first photo we analyzed was the photo at the back of the tower, which had "How far down can you read?" and we were only able to barely read the first two lines, as the camera that came with the Blue Heron drone was not high quality enough to get any more letters. Though, in our walkthrough testing, we were able to get much higher quality imaging by using a GoPro instead of the camera that came with the Blue Heron, but we were unable to use this in the actual fly-off because we simply did not have enough time to mount the GoPro onto the Blue Heron and fly it out. Another observation we made was at the top of the tower there was a device that had glowing lights on it, and it showed orange, red, green, and blue light, though we were informed after the competition that there was a fifth light on it, but it was non-functioning on the unit we were given. So what we noticed about the picture on the ground was that it was the Perseverance landing site, the Jezero crater, which we found after researching what the image could be. And the image on the tower we found to be a fossil which was excavated by Bob Simon, being a nearly complete Camarasaurus in Wyoming. And something that we noticed in common with all of these photos is that they represented different things that we might be able to find on Mars or be helpful on a different planet, like how the landing site was, of course, the place where we'd land the Perseverance or any other kind of drone or rover, and the fossil is a sign of old life that would be very interesting to us as humans, and the "How far down can you read" represents maybe hieroglyphs or symbols laid out on the landscapes, and the lights might represent a natural phenomenon like the aurora borealis or technology from possible life on Mars.
This is Censor Suite 2. It was paired with the drone camera to measure the distance and height of certain objects. It has many of the same workings as Censor Suite 1, with the same microcontroller, LiPo battery, and SD card reader. It also has a Maxbotics ultrasonic distance sensor, which works kind of like sonar. It also has a BMP 280 sensor, which was used to measure altitude and pressure. It also has twist ties to adhere to the drone, and we use tape on the wires to make sure that those didn't get in the way too much. And we had to solder it, of course, as well. So for the walkthrough data, which we use telemetry for as well, We got temperature versus time, which stays steady. We didn't notice very much change in that. And next we have altitude versus time, which we saw a change in about 4 meters, which is about 12 feet, which seems plausible because that's about the distance that we were traveling up and down in the drone. And next we got pressure versus time, which didn't change all too much, which is a good thing because if you're just going up and down 12 feet, you're not going to see much change in pressure.
So before the competition, we had created a graph that could take a reading from the distance sensor as well as a measurement from the photo to be able to give us the actual measurement or predicted measurement of an object. So we did that for the depth and width of the tray, and we found that the depth of the tray was about 31 centimeters and the width was about 46 centimeters. We did this for the height of the bucket as well, and found it to be about 28 centimeters. And we used that information from the tray to be able to calculate the different distances on this overhead image to be able to create an approximate map of everything. And so I did that, and I realized that there was lots of lens distortion in the depth of objects. So since we knew that the landing area was square, we used that and a formula to be able to remove some of the lens distortion on all the other depths. And finally, we found that the actual exploration area was more of a trapezoid rather than a square, or a rectangle. And that lined up with what we found with the distances being the closer area 8.1 feet and the farther area 9.3 feet, all with a length of 23.1 feet on each side.
For our sample collection device, we used a coat hanger taped to the bottom of the drone, which we then put coat hanger bars that we would swap out in between sample collection flights. For our liquid collection, we used a paper towel clipped to the bottom of the coat hanger bar. And for the solid sample collection, we used a piece of gaffer's tape on the bottom of the coat hanger bar. For our liquid sample collection, we were able to collect over 1.8 milliliters of a water sample. We noticed right away that the water was slightly cloudy and a light brown color, and it was cold to the touch. When looking at the paper towel we collected the water with, we can see that there are some dirt pieces and possible wood fibers in the water sample. And so when we did a microscopic examination of it, we were actually able to find plant and food debris. Most notably, we found stellate hair from a plant, as well as other plant and food debris under no stain and an iodine stain. For our soil sample collection, we were able to collect 0.4 milliliters of sample. Right off the bat, we noticed that there was a mixture of material, something that kind of looked like sandbox sand, and we also noticed that the sample was magnetic. And so we put this under microscopic examination, and we were able to definitively identify quartz, hematite, and iron. And iron is really important since this could be used as a resource. We also speculate that there could be trace of bornite, orange calcite, fluorite, olivine, magnetite, zircon, and pyrite in the sample.
So we must say great thanks to all of these people listed on the screen, as they had helped us in various processes and data analysis throughout the competition. And finally, we use this as a learning experience to figure out the thought process that many of the people, especially on the Perseverance drone mission, went through. And we found many different things that a lot of people would find interesting, like life on Mars with fossils and technology, as well as water, which is vital for human life. So we were able to analyze all of this and make something, or find something that was very interesting to us and everybody that could have been involved.